All right, as threatened and or promised at the end of the last video, we're going to go ahead and run that debug IP packet now, and we're going to run it while we're pinging something that we could ping. We know what that one was, 170 router 2 serial 0 interface. Then we'll run it for router 2's loopback interface, which we could not ping. Those pings are great, but they don't give you a ton of information. Let me move that up just a bit. It's just that simple. Now, in a busy production network, this screen would already be filling up with information. So like I said, you got to be really careful where and when you run this one. Right now, in a lab environment where we don't have any routing protocols going on or operating, we're not sending any packets yet, we're not going to have anything. So don't let that fool you the first time you run it in a lab environment. Also, in a lab environment and a production environment, when you're running debugs, when you're turning them off and on, when you're trying to troubleshoot a problem, you can get a little foggy at one point on which debugs you're running and which ones you're not. All you have to do is run show debug, and it's going to give you a full list of all the debugs that you're running. Also, let me throw this in real quick before we start with that those pings. When you want to turn the debugs off, you can just put the word no in front of the debug, just like that. 99 out of 100 times when you want to negate something you've done in Cisco, just put the word no in front of it. No debug IP packet will turn that debug off. You'll get a little message. Also, you can run the uall command, and that's going to turn all of your debugs off, and that is short for undebug all. So that's a great one to run before you leave a client site, just to make sure you've turned off all your debugs, because you do not want to leave debugs running and then all of a sudden their network gets busy and they're having some problems because of it. So let's go ahead and ping, after we turn the debug back on, of course, let's ping 172.12.123.2. And this is what a successful ping looks like when you're running this debug. You're still going to get the 5 exclamation points because we ran a ping. And sometimes these will appear in a neat row up here, and once in a while you'll see them down here in the information. So you have to be careful with that. The key here with the information we got is here at the end, sending and received. And received, of course, is short for received. We sent 5 packets out. We've received 5 packets back, which is exactly what we want in a ping. Now, move that right back over. Let's ping an address that we know we can't connect to. And you'll see the periods for the timeouts here showing up at the end of this particular line. You can see them right here. So like I said, they won't always be in a neat row. But what we should be much more concerned about with our neat row is that we have 5 unroutable packets. And when you get the word unroutable and you're trying to route, that's really, really a bad sign. So why are these considered unroutable? Any ideas there? Let's look at the route table and figure it out. Here are the 2 routes that R3 knows about. It knows about the 2 directly connected routes, and that's it. So when it tries to look for a match for 2222 in here, it's not going to find anything. Also, there is no gateway of last resort set because, of course, there isn't one of those by default. There couldn't be. So the router just finally goes to, if router sends a packet to the routing engine, looks us up in a table and says, what do you want from me? There's no match here. I can't do anything. So that's why you're getting these messages that tell you unroutable. But the only way we saw that was to run the debug IP packet command, because the ping wasn't telling us that. The ping was just saying, I can't get the packets there. We didn't know if the packets were leaving. These packets aren't even leaving the router. So that's about as bad as it gets. So that is how a debug can really help you spot what's going on beyond just running pings. Not down talking pings, of course. It's usually the first troubleshooting command you're going to run, but it most likely will not be the last. So let's see if we had anything else on the board, and we've got the unroutable message there. And you can see I told you about undebug all, turning off all the debugs. We have 2 choices now on how to get a route to that network into this table. Now we could configure a static route, or we could configure a dynamic routing protocol. And if we configure the routing protocol, of course, we have to configure it on every router in this network. It wouldn't do us any good just to put it right here. Now, since we're in the static routing section of the course, let's go ahead and create a static route. We use the IP route command to create static routes. There's an easy answer for you to a question, but we have a lot of syntax here we need to be very familiar with and some options we need to be familiar with as well. Because what they could do on the exam, and what I've done in job interviews, is handed somebody a list of 6 IP route commands, shown them a network, and said, okay, which IP route commands would be good for this particular network. So we've got to know the syntax down cold, and we will. Now in turn, when we decide to create static routes, we have a couple of choices. I put them in 2 rows, but technically we have 3 choices. We can create a static route to a given host, one particular device, or to a destination network, which is probably going to be your choice. That's you're going to do that a lot more often than writing a host route. If you need a host route, and I wanted to tell you the name of that, if you write a static route to one particular device, that is what we call a host route. It's going to be good for one and only one destination. So we could do that. We could write a host route. We could write a normal network route, destination network route. Or we could write a default static route. And a default static route is going to be used when there's no other match in the routing table for a destination network. Default usually means, hey, we're going to use this first, or here's the setting we're going to use if you don't change anything, right? But in this case, when we're talking about routing, the default static route really is that last resort. It's okay, we didn't find any more specific matches in the table, so now we're just going to use this default static route. Again, be very familiar with these options for the exam and the syntax, and we're going to see all of that along with a bit of iOS help material here. So let me put that on the screen. We're going to be going back and forth between the screen and the router here in a moment. But with iOS help, another great study tool. Just look at the options. It's amazing how much you can pick up just using iOS help and looking around at the options, even if you don't need an option at that particular time. Because you're not going to break anything. You're not going to bust a lab router by looking at iOS help. So please go ahead and do it. There are actually 2 different ways you can use iOS help. One I think you'll use much more than the other, but let me show you both. Let's go ahead and bring the router back up. And if I start right here, do a config T with IP route. Now, if I don't leave a question mark between the E and the question mark, there's no space there. This is a very important distinction. It's going to show you all the entries that could go after IP here that begin with ROUTE. Now, you might think, well, how am I ever going to forget IP route? You probably won't. I don't think you will. But every once in a while, you'll be typing right along. It's like, wait a second, that word, the next letter begins with C or CON, something like that. So you could go back and put CON here, and you could see options unless there aren't any, and then it's going to say it's an unrecognized command. Now, the way that you're more likely to use iOS help is by leaving a space after this and then putting a question mark, because then that shows you the next options that you have. Also, it's going to tell you if we have a completed command or not. If you do not see CR right here in the little arrowheads, whatever you want to call them, if you don't see CR there, that means you have an incomplete command. And if you enter an incomplete command on a router, this is what it's going to tell you. Just incomplete command. No mushroom clouds coming out of the back, anything like that at all. It's just going to say IP route, incomplete command, you got to give me more. And every once in a while, that's going to catch you by surprise because you'll be working on it. It's like, well, I thought that was the full command. Then just use iOS help to see what your options are. Now, speaking of our very important IP route options, profile and VRF, just leave those alone for now. The only thing we're really concerned about here is the destination prefix. And here, we're going to go with 2220. Again, if we wrote a route to 2222, that would be what we call a host route. And let's see, so we've got, now we need the destination prefix mask. It doesn't seem too complicated yet, right? So we're going to give that a 24-bit mask. And now we're getting a few more options here. And depending on what kind of router you're on, you could get a lot more options. So don't let it throw you, because you really have two choices here. You have what the router refers to as the forwarding router's address, which is always going to be the next hop IP address. All of the other choices you have are interfaces. And you'll notice here it gives us an Ethernet, a loopback, a null, and a serial, because that's what we have available on this particular router. If we specify an interface, it's always going to be the local router's interface. If we specify an IP address, it is always going to be the next hop router's IP address that will be receiving the packets. Now, you might think that makes perfect sense. I hope you do, because that's the way it works. But again, you want to watch that on any kind of multiple choice question on your exam. Again, if you're specifying an IP address here, it's the next hop address. If you're specifying an interface here, it is the local interface. Now I want you to see what happens if I try to use the local router's IP address. So I'm going to put 172.12.123.3, which would be incorrect on an exam, hintity hint hint. And then I'm going to use iOS help to see what my other options are. The remaining options here, distance metric, name, permanent, and tag, don't worry about them. They are for your future studies. They're not going to show up on the CCENT exam. But look at what we have now. We have a CR where we didn't have it before. And so now we know that we've got a legal command, and I'll hit enter. And I love this output. It says invalid next hop address, and then in paren, like it's whispering to you, hey, it's this router. I love that. It's like, I don't want to embarrass you, but you used the wrong command. But of course, on the exam, if you had a multiple choice question, it's not going to tell you, hey, this is an invalid command. So it did not allow us to put that in. Let's put .1 in instead. And that's it. So it's IP route followed by the destination, whether you put a network or a host in there. Then you've got your mask, your network mask or your host mask, which would be 255, 255, 255, 255 if it was a host route. Then your next hop IP address or local router exit interface. And then that's it. So let's take a look at our routing table and see what we see. And now you can see that static route. So see, we're already adding routes to your knowledge base. C for connected, S for static, I for IGRP. You don't even have to worry about that anymore. That's gone. And we'll talk a little bit about rep, but not very much because they've taken the configuration of that off of the CCENT exam. But we've got our static route. Here it is. And it's got our next hop IP address. Looks good to me. So now, is router 3 going to be able to ping router 2's loopback? I mean, it's got an entry right there, right? And I'm not tricking you. I don't ask these questions and then hide stuff, but I do like a little participation. I know I can't see you right now, but when I ask this question, answer it. And just say, hey, yes or no. So we've got ping 2222. Let's see what happens. And wow, that's kind of different output. That's a little odd. So like I said, you've got to watch this. And if you want to see your ping characters all in a row when you run a debug like this, because the debug was still on, and here's a U up here, which I think was part of the output we were supposed to see, right? Let's see if we see anything else in there. There's a dot and a U and a dot and a U. So I have an excellent idea. Now that we've turned the debug off, let's send that ping again. Wow, that's pretty wild, isn't it? U.U.U. That is a rather strange output. It's one you don't see very often. So what in the world is causing that? Well, according to the timer, we're going to have a bit of a cliffhanger here, but you don't have to wait until next season or next cycle. All you have to do is go to the next video, and we are going to troubleshoot that and fix it with another kind of static route. So I'll see you on the next video.